Good morning, good afternoon, and good evening, everyone. Welcome, everyone, to the Application of Nanotechnology in Seed Enhancement webinar session 3 of Seed Technology. So before we start, I would like to inform you about our 2 minutes housekeeping rules. In this webinar, participants are not allowed to open microphone or camera. So if you have any question or any technical issue, please put it in the chat box. And if you want to ask questions to speakers, please put it in the Q&A box. So remember, question to speakers, Q&A box, chat box for any technical issues. Participants can also click like to upvote questions. Questions that got most like will get priority to be answered by the speakers. With that, we would like to thank our sponsor, COAT, or Korea Agriculture Technology Promotion Agency, to make this webinar happen. So let us watch a video from COAT.
우리의 식량 주권, 종자 산업이 미래다. 온라인과 오프라인으로 누리는 2022 국제 종자 박람회. 4차 산업기술과 융합한 종자 산업의 무한한 가능성. 국내외 종자 산업의 최신 정보와 다양한 체험까지 대한민국 종자 기술의 우수성을 널리 알리고 종자 산업의 무한한 가능성을 점검해보는 시간. 10월 13일부터 15일 온라인과 오프라인으로 만나세요. 씨앗, 미래를 밝히는 성장 동력 2022 국제 종자 박람회.
Thank you, COAT, for the sponsor. So next, let us start with the opening of the webinar. May I invite our member of APSA Standing Committee on Seed Technology, Dr. R. Rajashikran, to open the webinar. Dr. Rajashikran is the Vice President, Quality Assurance of SeedWorks. He holds a doctoral in agriculture with specialization in seed science and technology. He has an experience working around 17 years in seed quality assurance function, where he has been involving in contributing to standardization of seed methods, seed enhancement techniques, new seed treatment recipe, process optimization, and other seed technology trials. Dr. Rajashikran, the floor is yours.
Thank you, Ms. Kuna. A good day to all of you and warm welcome to this webinar. I appreciate all the participants for registering to this interesting webinar on application of nanotechnology in seed enhancement. At present, the world population clock is ticking at 7.98 billion, and it's expected to be 8 billion in mid of November 2022. On the other hand, the awareness on the environment and use of sustainable practices in agriculture is increasing. It is need of the hour. We should use the available resources smartly, efficiently, and also judiciously. Use of advanced technology and innovative ideas in agriculture is inevitable to meet these requirements. We all hear the word nano very frequently, isn't it? Nano is smaller. How small it is? Nano is 1 billionth of a meter. The history of nanotechnology started with a physicist known as Richard Feynman. Classic talk on there is plenty of room at the bottom in 1959. Later on in 1980s, with the development of scanning tunneling microscope, the modern nanotechnology has begun and spread its wings in many fields. Today, we can see the nanotechnology applied in multiple functions. Nanotechnology is considered as one of the key technology that promises to advance the traditional agriculture practices and offer sustainable development. The main objective of nanotechnology is to improve the effectiveness and sustainability of the agricultural practices by putting less input, because this is one of the important requirements, putting less input and generating less waste than the conventional products and approaches. We have two eminent speakers for today's session, Dr. Subramanian and Dr. Alok Adholeya, with us for this webinar, who have extensive expertise in the field of nanotechnology. The first part of the webinar covers the seed quality assessment and enhancement through the nanotechnology and the different options available with us for using this tool. Any technology is a tool for improvement. To have the fullest potential, we also should know how to use it appropriately. The second session of the webinar covers the regulatory aspects of agri-nano products and technology. With this brief introduction, I would like to invite Dr. Jagdish, member of Standing Committee on Seed Technology, to be the moderator for this webinar. Dr. Jagdish has been with APSA Seed Technology Committee since 2020, and he is currently the head of the QA and ISTA accredited laboratory of the Indo-American hybrid seeds. He has been with this organization since 1999. Prior to that, Dr. Jagdish was the professor at Department of Seed Technology at the University of Agricultural Sciences, Bangalore. He is also a member of ISTA Vigor Committee and group leader for conducting radical emergence tests in tomato and sweet pepper during 2016-18 and further continued during 2019 to 21. Dr. Jagdish successfully organized many ISTA workshops. Of course, he is well known for giving a lot of ISTA trainings in the industry. We also got trained by him. He has organized many ISTA workshops in 2008, 11, 12, and twin workshops in 14, 18, 16, and 17, and in 19. He is also member of ISTA Technical Committee on Seed Storage. The floor is yours, Dr. Jagdish. Over to you. Thank you.
Yes, thank you, Dr. Rajshekharan. So, hello, everyone. So, good morning, good afternoon, and good evening for all participants. I welcome Dr. Subramanian and Dr. Alok Adholeya and distinguished speakers of the day and members of the Seed Technology Committee, Dr. May, Executive Director, APSA, and Puna and APSA Secretariat, and Mr. Johan, APSA Seed Technology Chair, and Dr. Manish Patel, Co-Chair, and members of the Seed Technology Committees. So welcome to the third seminar on application of nanotechnology in seed enhancement. We have a record number of participants registered, which shows their interest in the topic of today's discussion. So agriculture is currently facing many challenges, including production losses due to pests. The effects of global climatic change and the depletion of natural resources or the additional difficulties, and that the transitional agriculture practices have been relying on continuous application of pesticides and fertilizers, resulting in environmental contamination. As you know, the world population is expected to increase to 9 to 10 billion by 2050, implying that food production will need to rise by 25 to 70% compared to the current level. Therefore, the new technologies need to be deployed in agriculture to ensure sustainability and increase in productivity. Nanotechnology has the potential to contribute to the new technology-based agricultural revolution. Many nanomaterials have been developed for agricultural applications, including new solutions for soil and water remediation, as well as fertilizers and nanopesticides, designed to reduce the applied amount of fertilizer and pesticides while increasing the food production and quality. Nanopriming can be applied to seeds in order to provide protection for seeds during storage, improve the germination and synchronization and plant growth, as well as to increase the resistance of crops to abiotic and biotic stress conditions, which can help to reduce the required quantities of pesticide and fertilizers. The use of nanotechnology for seed priming is a new area of research. Seed nanopriming also can be used for seed protection, as many nanoparticles have antimicrobial activities and also can load antimicrobial agents. In addition, nanopriming can be used aiming the biofortification of seeds to promote an increase in food quality and production. So with this background, we have today's program, the first distinguished speaker, Dr. K.S. Subramanian is our first speaker, who is a professor and head, former director of research and an NABARD chair. And he is and also he is a well-known agricultural nanotechnologist. He did his PhD from the University of Ottawa, Canada, and has more than 34 years of research and teaching experiences in the field of nanotechnology in agriculture and soil biology. He is a founder head, and he has assisted the ICR in developing research framework on nanotechnology platforms in agriculture. He is also the PI, principal investigator of several international and national projects, I think several worth $5 million, funded by the Global Affairs Canada, GAC, International Development of Research and Center, IDRC, and also Department of Science and Technology, Nano Mission, besides ICR. He has significantly contributed for the development of nanotechnologies for fruit preservation, design and fabrication of nano agricultural inputs, nano-based on-site detection kits, which are of very much practical. Also, Dr. Subramanian has a major contribution in the regulatory framework of the usage of agri-nano products, and it has been validated by IFCO, our nano urea, which is the first ever nano fertilizer. He is one of the members of the Parliamentary Standing Committee to provide evidence of support of nano fertilizer. His contribution has very much contributed to the Indian agriculture in saving farmers for the inputs and also high productivity. I now request Dr. Subramanian, over to Subramanian for your delightful talks. Thank you.
Thank you, Dr. Jagdish, Dr. Rajasekaran, Ms. Gunal. Good morning to all of you from India, and good evening those who watch from United States or the western part of the world, and good evening the eastern part of the world. And I am very thankful to the organizers for giving me opportunity to speak and share my thought, nanotechnologies for seed integration. And nanotechnology, as mentioned by the speakers earlier, it is a very emerging areas of interest, and the TNA is one of the leaders in nanotechnology research in India. And you could see the bottom of the screen, you see Tamil Nadu Agriculture University. It was built in 1909, exactly 100 years later, we came to existence in nanotechnology research. In between 1959, the year was mentioned by Dr. Rajasekaran, which is very important year for nanotechnologies. And Dr. Richard Feynman mentioned plenty of space at the bottom. And that was a trigger for us to choose nanotechnologies, one of the areas of interest for agriculture. And we have done nanotech research for the past 12 years. And I'm also very happy that I'm sharing the floor with Alok Adholeya. And we both were in nanotechnology in agriculture for about 10 plus years. Next. Can I have the next slide, please? And as many mentioned, nano refers to 1 billionth of a meter. For a common man to understand what is nano, I always refer to Indian population. India has 1.38 billion people at this time. That is, it is referred as 138 crore. We queue them in 1 meter length. Each Indian is the size of a nanoparticle. When the size get reduced, the surface area get tremendously improved. You take an example of a cube which undergoes a division after division 24 times the division, it becomes a nano-sized particle. The bulk material has a limited surface area. When it becomes a nano size, the surface area increased tremendously one cube can undergo 24 times a division. You get a nano-sized particle, you can spread the football stadium, that is the surface area it has. And also at the bottom of the screen, you're all familiar with coronavirus, which has a dimension of 50 to 120 nanometer, which means you can get a coronavirus building with 50 to 120 nanoparticles. And also in the bottom of the screen, I am showing human hair. Across a human hair, you can assemble 80,000 nanoparticles. So all this explanation indicates that nano is very, very small. The surface is tremendous. The high surface mass ratio is a unique property of nanomaterials. So that's what we exploit in nanotechnology and agriculture in general. And for this seminar, I focus on how exactly seed technologies can take advantage of the nanotechnologies. And also the word nano refers to dwarf. You're all aware of bonsai. Typically, the nano word refers to dwarf, miniaturization. The nano is small, but it is very smart in action. That's what we exploit in agriculture. Next slide, please. So there are three important areas. Though we have done lots of work, as the introducer mentioned, we have conducted several projects. We have got lots of information to share. But for this seminar, I just focus on three important areas in which how seed technologies or seed industries can make use of the nanotechnologies. The first and foremost area is nanodiagnostics. Very important. The seed is a very important input in agriculture. As M.S. Swaminathan, the father of Indian Green Revolution, he always said that the seed has an influence in productivity of crops. The seed diagnostics is very important. The timely diagnosis will help to improve the productivity of crops. Seed integration, there are n number of nanoparticles are used for improving the germinability, improving the vigor of the seeds. Also, the seed could be a smart delivery system. You can seed itself as a nano product in nano input in agriculture. We can do many manipulation in seed so that it can improve the productivity of crops. So my presentation will cover nanodiagnostics, seed integration, how nanoparticle or nanotechnology will help in improving the viability or vigor of the seed. The thirdly, it is on smart delivery of input. You can deliver nutrients, bioinoculants, hormones, and pesticide using nanotechnology. Can I have the next slide, please? In nanodiagnostics, as I mentioned, seed has to be analyzed for its quality before sowing. And as we know, in India, 60 to 70% of the area under rainfed agriculture, once the rainfall received, the farmers, tempted to sow the seed immediately. They will not have much time to check the seed quality. Traditionally, seed quality is assessed with the tetrasolium test. The classic method is being used for the past several years now. ISTA recognized this is a classic method in which seed testing is done. The nanotechnologies come up with the three important ideas how on-site detection of quality could be done. Can I have the next slide, please? And again, there are three methods. I'm going to show you the first method, how the seed quality can be assessed with the eNose technology. It is referred as electronic nose technology to assess the seed quality. The seed, whether it's rice or peanuts or pulses or any seed for that matter, it undergoes deterioration during the storage. And the seed produces wide range of volatiles. We call it as VOC, volatile organic compounds. They are the signature molecule. Depending on the quantity of volatiles produced, depending on the type of volatiles produced, they are all referred as a signature molecule. So currently we have done some work on groundnut as well in sunflower, where we collected the volatiles and measured the volatiles and relate the how seed quality is related. So we have come up with the 80 to 90 volatiles, 90 types of compounds from VOC, and of which there are 3 or 4 compounds are very critical compounds. They are closely related to the seed quality. Alcohol, aldehydes, and ketones. These are the 3 or 4 compounds. They are very related. And we establish a close relationship between the seed quality and VOC compound. And based on that, we are in the process of developing eNose technology, electronic nose technology, where we collect the volatile and pass through the nano system, where we can detect precisely how the volatiles would be linked to the quality of the seed or germinal of the seed. And these compounds serve as a signature. We can convert the VOC profiling into electronic signal, where we could see the specific compound relating to the seed quality can be assessed. So as of now, as this time, we have found out that acetaldehyde is a very good signature to assess the seed quality. And this is what we are in the process of developing electronic nose using acetaldehyde as a signature. Also, hexanaldehyde as another molecule which has close relevance with the seed quality. So simple, instead of using the classic method of tetrasolium test, it takes overnight soaking, where you change the biochemistry of the seed and you come up with some percentage, and you come up with 80 to 90% germination in the laboratory. It may or may not happen in the field. And this type of test will help on-site detection. Where the farmers, we can discriminate good or bad quality of the seed by doing this practice. The second method, next slide, please. The second method is electronic tongue. It is also equally important. We have done some work related to some of the seed crops like peanuts and pulses, where we take soak the seed, and within 2 hours of time we take the extract, and we made an assessment how it is related to seed quality. Unlike the tetrasolium test, it is overnight soaking. It takes about 2 hours. You take the extract from the seed, and this sensor will help in detecting the seed quality instantly. So we take the extract. A drop of extract is placed in a platform which is made of hydroxyapatite polyamine. That's a substrate. It is connected to the sensor, where we put the potassium chloride saturated point. It is similar to pH measurement. This is what the seed technologists traditionally they do. They measure the electrical conductivity of the extract. They relate to the seed quality. So at the bottom of the screen, I'm showing a table indicating the storage time at different month 1 to 6, and you measure the electrical conductivity. It did not change much, though it is a very good indicator. This is what maybe 30-40 years the seed technologists were using. This is a parameter, is an indicative of quality of the seed. When we look at the specific compound like acetic acid, so that we take the 1 ml of the extract and put it in the platform, that converted to electronic signal, and it gives a very clear information that the wide range of values are observed, and we could see this could be a very good indicator. This we call it the e-tongue or electronic tongue to measure the seed quality. Again, this is in the development stage, and both the devices, I would expect in a 6 months to 1 year time, we will have the devices ready for commercial use. And the third important measure, next slide, please. The third method is infrared spectroscopy. As another non-destructive method, there is no preparation of sample is required for the seed quality analysis, where we use FTIR, Fourier transform infrared spectroscopy, and X-ray spectroscopy, and we use combinedly to measure the quality of the seed. And you could see at the bottom of the screen the seeds that are poor in germination versus the seed which is high vigor seed lot, where we could see there is a distinct difference in IR spectra. So by doing this IR spectrum, we can discriminate good and bad quality of seeds, and again on-site assessment is possible by doing methods. So all the three methods are very important, very precise. As I mentioned in the e-tongue technology, so the traditional method, you give a very narrow window. On the other hand, if you look at the other method, you will have wide range, so that we will be able to precisely predict whether the seed lot in the range of either worst lot or the good ones are in between. We can do that. All the three methods can be used. The nanotechnology can help in detecting quality of the seed. The second part of my presentation, next slide please. The second part of my presentation on seed invigoration. The first part is the detection is very important. The second part, how to make the seed to improve the seed quality or improve the germinability of the seed. Again, we have got 3 or 4 nanomaterials that can be used for treating the seed to improve the quality of the seed or germinability of the seed. The second, next slide, please. So, how exactly nanoparticle works? There are n number of nanoparticles. I have written several reviews on this particular aspect, where I could see the zinc oxide, titanium oxide, and silica. They are all the very good nanomaterials that can be used to treat the seeds. The germinability could be improved. There are 3 processes that are going on in the seed that improve the germinability of the seed. The first and foremost thing is this in this particular case they used silver nanoparticle. The nanoparticles are by property, by physical property, they are tougher than diamond. When the nanoparticle hit the surface of the seed, it makes a permeation, and the water can easily enter into the seed, that improve the germination. And secondly, the nanoparticle help in squinching of reactive oxygen species, as we all aware of seed deterioration process. Thirdly, the nanoparticle help in the starch hydrolysis that improve the availability of glucose or improve the energy status of the seed, that leads to improved germination. So these 3 processes are very, very important. These 3 processes are responsible for the seed invigoration. The firstly, the creation of pores on the seed coat. Number 2, the reactive oxygen species are quenched. Number 3 is the starch hydrolysis. Let us look at some of the important nanoparticles, how it is helping in improving the seed germination. Next slide, please. The zinc oxide is a widely used nanoparticle. Only 1 gram per kg is recommended. When we look at this is a legume seed, it's a black gram seed, which looks very smooth when we by the naked eye. Under the scanning electron microscope, you will see lots of cracks on the surface of the seed, which indicates the poor quality of the seed. Under such situation, we can treat the seed with zinc oxide at the rate of 1 gram per kg of seed. When you do this, there is a reduction in lipid peroxidation. You could see the fresh lot versus aged seed, where the lipid peroxidation has significantly reduced when the seeds are treated with the zinc oxide. Zinc oxide is an excellent nanomaterials that can be used for improving the germination. Of course, Dr. Alok Adholeya would know zinc oxide also have the negative effect. That's why we are very careful in recommending this particular material. But it's a very good nanomaterial. We are going to use only 1 gram. So our recommendation is that we can use close to micro sized zinc oxide, so that it will be safer. At the same time, we take advantage of that. Another unique advantage of zinc oxide nanoparticle is it kills most of the seed-borne pathogens. And you could see Macrophamina phaseolina, which is totally wiped out when we look at the scanning electron microscope. You could see the distortion of mycelial growth on the surface of the seed. Again, there is an advantage that zinc oxide can improve the germination. Next. So another nanomaterials which is widely used for improving the germination is the carbon nanotubes. Carbon nanotubes is easy to synthesize in the laboratory condition. So we use carbon nanotube. This is one of the classic paper published 10 years ago. Very good paper from US, and they use a multi-wall carbon nanotube to treat the seed to improve the germination. There are two processes going on when the seeds are treated with multi-walled carbon nanotube. As I mentioned, for zinc oxide, it helps in the permeation of seed coat because, as I mentioned, the nanoparticles are tougher than diamond by its physical nature. It makes pores on the seed coat. Also, the carbon nanotube will serve as a water channel. It channelizes the water. Especially rainfed agriculture, when the water is extremely low quantity in the soil, certainly this carbon nanotube facilitate, channeling water from the soil to the seed that leads to improved germination. You could see the germination get improved, or the vigor get improved. The speed of the germination get improved with the carbon nanotube. So there is second approach in which we can do. The thirdly, the next slide, please. The third is, this is what in TNAU we have done. We have developed a nano emulsion, which is also very, we have been working on nano emulsion for about 3-4 years. And we have a seed technologist that is Dr. Rajam. And this product is commercially available now. What we did was we used a CMC, carboxymethyl cellulose, and we loaded the IAA and GA. Those are the hormones. We made an emulsion. When the seeds are treated with the nano emulsion, the seed quality get improved. And we could see this is in groundnut. We have done the experiment in groundnut, pulses, also cotton. And standard seed lot, we have there's a control has 76% germination. When the seeds are treated with 10 ml nano emulsion per kg of seed, they improved germination by 10%. The substandard seed lot, we can improve up to 10%, 10 to 12% seed germination. That's a very good hike in terms of improved germination. Particularly when the seed industries are watching this particular presentation, particularly the vegetable seeds, which are $1 million business, the seed quality can be improved by treating with nano emulsion or zinc oxide nanoparticle. So this is we call it seed vigor, TNAU seed vigor, which improves the germination. This we recommend for rainfed agriculture. Next, the thirdly, another important nanomaterial that can be used to improve the germination is the silica nanoparticle. So the advantage of silica is silica can be derived from rice husk or the waste, the fiber from the sugarcane, and we we loaded the nano silica with the biomollecule, and so that treating the seeds with this compound, with this nanomaterials, we can improve the germination. Also, we can ensure the protection against viral diseases. As I mentioned, the lateral flow immunoassay is well known to you. It is like a COVID test. We can also use this type of devices to detect viral diseases in crops. And this is the last one, a nanomaterial that can improve the germination of the seeds. Next. So the third and the last part of a presentation is on smart delivery. As I mentioned earlier, MS Swaminathan called seed is a smart input. Seed is a very important input. Seed decides the success in agriculture. The seed being any technology associated with the seed is of great interest. And we have done lots of work related to seed nanotechnology. And one such method we worked in this area for some time is encapsulation of seeds with the nanofiber. Nanofibers is made of polymers. When the polymer solution is subjected to high intensity voltage and the solution, it loses surface tension, the liquid becomes solid, and you get a continuous thread that is deposited on the seed. So you could see the left side, the machine is in operation. It's called electrospinning machine. Traditionally, we call it a cotton candy technology. So these are the needles in which the polymer is loaded with whatever the compound interest. And we have done, in the next slide, I am going to show you lots of things. And here the nanofiber, the beauty of nanofiber, the surface area is huge. 1 gram of nanofiber has a surface area of 10,000 meters square, close to 8,000 to 9,000 meters square, close to 1 hectare of land. The length is about 9,000 kilometers. That is the beauty of this technology. The nanofiber is a very powerful technology. The seed technologists can use this technology for multiple purposes. Next slide, please. So we use nanofiber technology to load lots of inputs. I got a couple of projects from DST Nano Mission, where my target was improving the productivity of pulses and oil seeds. And the nanofibers, as I said, it has extensive surface area. It has it has a length of about 1,000 kilometer, 1 gram. Almost you are giving an opportunity for one plant to exploit 1 hectare of land. So we did lots of work, and we could successfully load nutrients through the nanofiber. We successfully load bioinoculants, rhizobium, or whatever the biofertilizer that are recommended for a specific crop, that can be loaded, pesticide can be loaded, hormones can be loaded. So from the project, what we found was independently, the input can be loaded onto the seed as a encapsulation, and you can get equal yield as sort of normal cropping. So we made a comparison with conventional. In this particular case, we used nutrients. Of course, so pulses are poor man's crop, but they need rich man diet. They need lots of nutrients. We could successfully load all the nutrients. We could get the equal yield as sort of conventional fertilizer. In terms of quantity of fertilizer used, it is just 2 to 2.5 gram. That is 2,500 milligram per plant, reduced to only 40 to 50 milligram by doing this encapsulation with nanofiber. It's a very interesting technology. I wish the Seed Technologies can use this technology. Next. There is another, next slide, please. The nanofiber, which also we have done it for groundnut. And as I mentioned, for pulses, we could get comparable yield in terms of germination. There is an improved germination, about 12% germination improvement over control. So we can use the nanofiber technology for loading hormones, nutrients, bioinoculants. I would say that the entire gamut of agriculture input can go in one single coat as a single, we call it as a single solution through nanofiber technology. Next. The encapsulation seed with the nanofiber, again, we have done it for cotton. I think cotton, the industries are very much interested to introduce the technology, because cotton, the area under cotton has diminished because of the lots of pest and diseases. So we can introduce pesticide through nanofiber at the time of sowing, so that we can offer protection at least 20 to 25 days, so that the cotton crop could be protected. So in short, I would say the nanofiber technology is a very important technology, and any crop, it is not a crop specific technology. Only thing we have to design and deliver a specific compound for a particular crop, so that the productivity can be improved. So these are the important areas, and TNAU has been working for the past 3-4 years now in this nanofiber technology, 10 years in total on nanotechnology research in several crops. So we can improve the, you could see there is a 16% increase in germination, and vigor index is better, and you can put almost all the nutrients, all the input that are required for crops can be loaded together. As another advantage is in India, though we have lots of people still depend on agriculture, you don't have people to work in the field. So this is going to be a very interesting technology, where at the time of sowing, we can put several input together so that they can sow, and next time they go only for harvest. So that type of technology we develop using nanotechnology. Next. So next slide, please. This is one I just want to, I think this is last slide for me. And previous slide, please. So I spent a few minutes here. And IFCO is a fertilizer industry in India, one of the major fertilizer industry. And they come up with the nano fertilizer. And at that time, we did not have a regulatory framework, and we developed, thanks to Alok and his GBT team. We helped in developing a regulatory framework. Alok will be speaking on that. But about the nano urea, which is a very powerful fertilizer, first nano fertilizer introduced in the country, and the TNAU is responsible for the scientific validation of this fertilizer with the help of TNAU data as well as the safety clearance. We could release this particular product in 2021, almost I think 4 crore bottle, which is 4 crore bottles of nano urea has already been sold out, and we are going to measure how much fertilizer import could be minimized with the help of nano urea. So we did lots of safety tests. Also, the point which I want to say here, we are seeing a drone which is delivering nano urea. After the introduction of nano urea, people find it difficult to spray in the field. So then we thought of using drones, and we used a drone. Drone takes about 2 minutes to spray 1 acre. Even if India is more of small and marginal farmers, which is 1 acre, 2 acres, even that small areas, we can use a drone. So we optimize the several parameters to deliver nano urea using drones. And Seed Technologies can use a drone for several purposes. Even TNA started working on sowing of seed, particularly rainfed agriculture, with the drone, and we can put several input using drones. Drones would be another potential technology. It is all connected because the nano input is so small. Either you can use the seed as a delivery system, or a drone where we use the smaller quantities of spray fluid, we can use it. And also very important information which I want to pass on in the crowd is that the Indian Parliament wanted to know more about nano fertilizer, as well as nanotechnology used in the country. And I had a chance to speak in the Parliamentary Standing Committee few times, and to clarify how exactly we can take forward to the next level. Of course, Dr. Alok Adholeya will speak on safety of these nanomaterials, and he will have lots of information to say. And to conclude this, nanotechnology is a very powerful technology. The nanotechnology and seed technologies are all inseparable couple, because nanotechnology is looking for a method or a delivery system. I find the seed is a very important smart delivery system. We can use the seed to deliver nanomaterials, and we can design seed in such a way that several inputs can be put together so that you can achieve productivity with minimal damage to the environment. My last note would be, though nanotechnology is very powerful, very useful, and we can achieve more from less, and at the same time we need to be very cautious. That's what we put it, the framework, regulatory framework in the country, that we need to follow the safety guideline so that the products can be recommended and people would benefit from this without environmental hazard. So that's what we want to say it as, seed technologies, seed industries watching this webinar. Some of the points which I raised, certainly we'll closely work with the industry, and those industries interested to join with us. My contact details are in the next slide, and I close with that slide. Next slide, please. So my contact details are given in this slide, and I have to thank all the sponsors, and the details are given at the bottom of the screen. You be in touch with us so that we'll be negotiating for the discussion. Thank you very much for the opportunity given, and I hope I completed on time.
Thank you very much, Dr. Subramanian. So may we invite the moderator for the Q&A session, please. Dr. Jagadish, if you are around. Dr. Jagadish, you need to unmute.
Yeah. So we had an excellent presentation of on the nanotechnology by Dr. Subramanian, and most of the pioneering work done at Tamil Nadu Agricultural University. So we have several questions by the many participants. I think we can go for the most important question, that is, what is the vigor index and how to, of course, measurement, because the vigor index, ISTA has given the detailed description of it. And the most pertinent question is, when using nano encapsulation, need to do priming for seed for improving the seed germination percentage?
Yeah, that's a very interesting question. When you do the nano coating with the nanofiber, as I mentioned, Dr. Raja is a seed technologist. And though we do the coating with nanotechnology, and the traditional methods are still followed, the germination percentage, vigor index, and root length, shoot length, those measurements remains the same. Whatever ISTA suggested, that's the standard methodology we use it for measuring those parameters. And at the beginning, the nanofiber coating, we started with the groundnut. We also did it with the pulses. There were some hiccups in terms of germination percentage, so that we rectified it. Though I made the presentation very simple to follow, it is more complicated than I speak. So we need to optimize several parameters to ensure that how much hour to be coating to be given, how the thickness to be done on the seed coat, so that we can maintain good percentage of germination. At the same time, we deliver whatever the inputs required. So we need to optimize parameters for several crops, whatever the crops you prefer to work.
Yes. I think it answers the question. And the next question is, can we load living organism onto the nanofiber for seed coating?
Yeah, yes, it's again another interesting question. We have loaded 3 or 4 bioinoculants. We have done it for rhizobium. That was my student has done the work, and we also did it for PPFM, pink pigmented facultative methyllotroph, PPFM, the microorganism which is recommended for drought tolerance. We got very good response, and we also published in Material Science that particular paper. So we have done it for few bioinoculants. There is a unique advantage of introducing bioinoculant, the nanofiber, is 2. Number 1, most of the time, because of the climate change and the temperature rise, the microbes that were recommended a few years ago, it's not effectively working now. So the nanofiber can protect from, it gives a thermal tolerance, because when we develop a nanofiber, we also look at TGA. There is a differential thermal analysis we do, and the tolerance at a high temperature. So it helps in that. Number 2, we also look at the longevity of the microbes. So when the microbes are loaded into the nanofiber, and we could see, because of the carbon source, basically is a polymer, it improves the longevity of the microbes, which can survive in the nanofiber. So it is certainly the n number of microbes, beneficial microbes in consortia mode we can do. Latest information which I've seen, publication, mycorrhiza spore, because Alok and me, we both are mycorrhiza specialists for our PhD and all. So mycorrhiza spore can also be loaded into the nanofiber, so that the longevity can be improved, the activity, infectivity can also be improved.
Yeah, I think there's one more question. From your experience, any observations of abnormal seedlings or plant in the use of nanochemicals while improving the germination rate?
Okay, from my experience is that one of the nano materials which I mentioned is very promising. At the same time, there is a caution needed, is zinc oxide. Zinc oxide, there are a few reports from China, somewhere in 2004, they used zinc oxide, and there is a negative effect. There is a reduction in germination. There is a rudimentary, the seed could not germinate, ungerminable seeds were reported at a very high concentration of 2000 ppm. 2000 ppm, that was in lettuce. So in our case, when we recommend this particular nanomaterials, we make sure that it is safer to environment. At the same time, we have a critical limit, like the dose, because the nanotechnologies, we look at toxicity in two different ways, like dose-dependent toxicity and size-dependent toxicity. Those sizes matter. We cannot go very low size of below 10 nanometer. It is more toxic. So we make sure that the size is optimum. Dose is also optimum. so that we can get a desirable results. Zinc oxide 1 gram per kg of seed for pulses or oil seed. It is very useful, and it can improve the germination. The size of the particle in the range of 50 to 60 nanometer, not extremely small size.
So one very practical question is, how do the local farmers get in contact with nano substances for their production?
Okay, the practical question is that I did not have space to present 1 or 2 slides about the university, and we have got 10 products ready for commercialization. 2 products for fruit preservation, which was extensively tested. I got a Canadian project of 12 crore, it's about $2.5 million, and which in that project we tested across the state of Tamil Nadu, even other state like Karnataka and Andhra Pradesh. That is a fruit preservation chemical, and people accept that formulation a lot. And we also developed a nano sticker, which is also based on nanofiber technology, which is a very powerful technology. A small sticker can preserve 2 to 3 kilos. So they are all well receiving. One of the practical information which can share my thought, because that's what I spoke in different high-level policy meetings, is the nano urea. So nano urea already, 4 crore bottles of nano urea has already been sold out by the companies, and now we are in the process of assessing how much reduction could be done. In none of the cases we got the negative results. We got a response for nano urea in the range of 4%, in some cases up to 40%. Nowhere negative results were reported. Also in the safety, we have done lots of safety tests, make sure that it is safer to the environment. So the people receive a lot, and now there are many companies, fertilizer companies, interested to invest money on nano fertilizers, so that the cost could be reduced, production continue to increase.
So one more question is, which viral disease is best? Any specific virus can be detected through this?
Yeah, detection, of course, our counter department, like NRC Banana, National Research Center, Banana has come up with viral disease detection in banana. And we have done it for mung bean virus, and the detection, we have just started working on that. But the best part is that the silica loaded with acidiractin offers protection against mung bean virus. So it blocks the transmission of virus at the stylet, because it blocks the viral transmission from the stylet of the insect to the plant. So we got the protection. So we have done it for mung bean virus.
Yeah. So one important question is where we get training to use nanotechnology in seed industry.
Okay. It's a very practical question. We have done last year. We have conducted one training. Not last year. In the month of March, we have conducted training on nanofiber technology involving 40 seed industries in the country, and we are going to do another training before December, and hopefully many industries come forward to register, so that we'll be able to give the training. Suppose any industry specifically they wanted a training, we have a crash course, which is a 3-day training program. So we teach you almost all the techniques involved in nanotechnology, so that seed industries can take forward. So we have lots of training program, and ICR is supporting us for faculty training. For industries, we have a special module, so we can offer training.
Yeah, I think some of the questions are regarding training itself. If it is given training, it will be good. How they say, what is the commercial availability of zinc oxide, and what is the learning formulation and application of nanotechnology, and also the IAA treatment to nanofiber. So all these questions could be answered by proper training, I think.
Yeah, training can be done, sir. Of course, for industries, the training cost is little more, because we devote dedicated time. As I said, it's a crash course, 3 days training program. we can teach you how it is synthesized, how it is supplied, and industries can benefit out of that. And there are lots of, I think before December, I also organized a big seminar so that more information can be shared. So I just shared a fraction of the outcome from the university, but there are many things to say.
I see. So I have one. Kuna, you have any time to question answers?
We still have 5 more minutes for Q&A.
I see. Yeah. So regarding what is your opinion on the green nanotechnology? Are you using commercial available zinc oxide nano for enhancing the seed quality?
Okay, the zinc oxide, one of the chemical companies, well-known chemical companies like Sigma Aldrich, they produce zinc oxide, but it is too expensive. 1 gram may cost, 1,000 or 1,000 plus rupees. But you have a simple method to synthesize zinc oxide in the laboratory itself, for which we have the standard protocol. It will cost only 20 to 30 rupees, less than 20 rupees actually. So we can teach you how to synthesize the zinc oxide in the laboratory itself, so that the participant would benefit. We have SOPs. We have been another important thing which I want to share in this forum is that the TNAU is the first state agriculture universities in the country. Started undergraduate subject in nanotechnology as early as 2008, and we also introduced masters in Nano Science and Technology in 2011. PhD program 2017 it was introduced, because we have got lots of student strength, and certainly we have more information than the other institutes. So we are expecting accreditation from ICR, so that these programs are very unique compared to other state agriculture universities. So there are universities in University of Agriculture Sciences, the Dharwad has some facility. Other universities also started working, and we'll continue to support all spectrum of participants, whoever it may be.
So one last question from me, sir. So I have a question. So whether these techniques have been validated by the ICRIP, ICR, or I think because since these are related to germination and vigor, even ISTA can go for a proficiency test and validate these methods and input it.
Yeah. Yes, sir. Last year, ICRIP wanted to introduce this technology. We already most of the ICRIP centers are testing this nano zinc oxide, because it's very useful, including TNAU is one of the testing centers. And as I mentioned, the 2 cautions have been given. One is the dose should be 1 gram per kilo of seed. Number 2, the size would be in the range of 50 to 60 nanometer, because the zinc oxide can also be synthesized a very less or extremely small size to below 10 nanometer, which may be toxic. So these are the 2 cautions. ICRIP across the country, they are validating zinc oxide.
Yes, yeah.
We can also supply, if anybody interested to get the materials, we can do that. We can also teach you how to make zinc oxide, very economic and cheap rate.
So thank you very much, sir, for your all the practical questions answered. And some of the questions could be answered by email because of the paucity of time. I think many people are eager to know the technology to be adopted in their quality laboratory and also subsequent use for the seed industry. So I thank you very much on behalf of APSA.
Thank you very much, Guna and others, Dr. Jagdish, for giving me opportunity to speak in this forum. Thank you all.
Sir. I know, so we have a power problem, so we are not able to have the video visibly. So the second speaker of this webinar is by Dr. Alok Adholeya. He is the founder and CEO of the TRIT, and he is a distinguished expert, and he has got several awards like Gwalior Ratna Award in 2000, and also Paryavan Sanskriti Sanman in 1999, and product and process and development of technology by the Government of India in honor of the outstanding contributions to sustainable production of plants through the innovative and dedicated research and development. So his Innovation of India Award also been conferred in 2010 by Marico Innovation Foundation. He has found ways to harness the power of synchronization mycorrhiza to increase the productivity of the crop plants and to restore degraded lands. Excuse me. So I hand over to Dr. Alok Adholeya for your valuable presentation, sir. Sorry for the interruption.
Well, thank you very much, the organizers, Professor Jagdish, Rajshekharan, Manish, and Kuna for having me here. It's been a pleasure to participate in this event, which is definitely very important from the point of view of seed and the crop productivity worldwide. The aspects that I would be touching with is regulatory aspects.
Sorry, Dr. Alok.
Yeah.
May I kindly ask you to close the reminder box on the bottom?
Sorry?
You have a small reminder box on the bottom of your screen open.
Reminder.
There you go. You need to close that because we are seeing your reminder box.
Okay.
Perfect. Thank you.
Okay. So basically, what's happening here? Yeah. Sorry for this inconvenience to all. So basically, I understand that we have in the audience a large number of seed industries, distributors, dealers, as well as researchers across from the universities and research institutions. So I would like to keep the presentation much more palatable from the point of view of understanding and also the messaging that are appropriate. Professor Subramanian is my friend, has already described you about what is nanomaterial. The important information is that you know a number of these materials shown on the screen, from mishal to liposomes and quantum dots. And the message is that these nanomaterials that we are talking about are much more smaller than these materials. So the materials which becomes smaller, become more functionally active, enhances the surface area for function, also comes with number of different cautions. And I do understand that when the word comes nano, lots of people do think about toxicity, hazards, and so on and so forth. Agriculture is already facing difficulties with the hazards from chemicals, and therefore there should not be any other material which should be adding to those problems. And I consciously feel that from the day one, when we started our research and journey in this area, we were definitely looking forward how we make sure that the output from this science becomes absolutely safe to the environment. And in this Quest, we try to develop the regulatory systems and frameworks which can help regulators worldwide and also within our country in India to see that the material which comes out are definitely of not only of importance, functionally beneficial to crop productivity, but also safe and securing environment. Now, the products that we are talking about in the agriculture area includes the nanonutrients, the nano carriers, nano biostimulants, which are the new emerging areas, and the nano products based seed coating. Now, seed, as Professor Subramanian mentioned about, is a very important commodity in the entire gamut of productivity and the food security. And therefore, they are important at the same time. They need to be dealt with in a manner by which they are enhancing crop productivity and bringing minimal resource and efficient resource system into the agriculture. So the number of different categories of nanomaterials, which we know, the nano carriers with the active ingredients, the active ingredient converted to nanoforms, and then there are organic, inorganic, and composite nanoforms. While we look at the regulation, we look at the regulation and the entire of those materials which are expected to come to the table of user. And from the synthesis point of view, there are biological, physical, and chemical nanomaterials. And the degradation point of view, there are two categories, biodegradable and non-biodegradable. So considering these categories of nanomaterials, the regulatory framework has been developed. However, before I go there, I also wanted to highlight the current problems with the products and the materials that we use in agriculture. The bulk fertilizer, of course, are one. And as you would agree that there are only few micrograms or milligrams of active in the bulk fertilizer. The rest is the material which is not wanted in agriculture soil. And therefore, loading those unwanted material has been creating difficulties. And therefore, the next level of science have gone to the water soluble or controlled release fertilizers, which have addressed to greater extent this issue of removing bulk from that from agriculture, but it still carries number of heavy metals and other materials which are not required. And therefore, even further, if there are a specific target delivery of materials which can provide the required benefit to crop production are needed. And that's one of the aspects that is being addressed by this piece of science that is coming to now to a level of translational research to a product. Limitation in efficient delivery is one of the another aspects, particularly with bulk fertilizers, and therefore the product which can pass through different screens, because the screen also are very important to be used in agriculture, particularly in the developed countries, and now even in the country like India, which is developing. And therefore, the fertilizers which are to be used have to go through all the equipments which are being used in the agriculture system. Obviously, the environmental problem due to bulk fertilizer or the water-soluble fertilizer is towards leaching issues, because there are excessive material which goes into soil, and that leads to the climate change impact. Cost is, of course, very important aspects from the point of view of making it to the end user. And therefore, if there are less cost and safer product with efficient delivery system, that is something which the crop production areas are looking forward to. And therefore, the nanonutrients and the aspects of seed coating and foliar products are coming up. The green and cost-effective methods are being emerging, and therefore there is a need of regulation which is required, and that is what the purpose was, that we tried to develop the guidelines for regulators so that they can develop and enact the efficient regulatory systems and regulatory mechanisms by which the not only innovations can be encouraged, the product can be encouraged to come to the table, but also there should be enough information for developing product and technologies, which helps these innovators to remain within those systems and guidelines and prepare those data sets so that the common concern of toxicity, common concern of the hazard that any material can bring into food system is taken care. And therefore, these regulatory guidelines, the policy guidelines that we have developed together with Department of Biotechnology has been very elaborating the aspects related to all those which are looking for developing these products. Now, the good thing is that these policy guidelines were accepted by Ministry of Agriculture and Ministry of Science and Technology, and two ministers simultaneously during COVID time have released these guidelines to the regulators and the country. And of course, these guidelines are available online for view. There were many different stakeholders have been involved in this process. The consultation process was very extensive, and in different phases, we have taken into account suggestions from different departments of the government and also the industries and end users, the farmers, and therefore their inputs have become very, very important and essential while we develop this policy document and release from the Government of India. The scope of the guidelines of these from these products includes different products that are emerging, and those are expected to emerge and come for use by the end users. Those are farmers, and that includes pesticides, fertilizers, agrochemicals, biofertilizers, pheromones delivery, plant nutrients, anti-transpiration agents, plant growth regulators, biostimulants, genetic manipulation outputs. And besides this, in the food sector, the finished food and feed, dairy formulations, nano processing aids, nano composites for food packaging and preservation, the nano composites and sensors made for nanomaterials. So while we develop this policy document, we consider that these products will be there, these technologies will be there, and considering them, excuse me, then these guidelines were developed. We have also considered the physicochemical characterization of the product that comes into the market or rearing to come to the market, safety assessment of those for the human health, additional assessment for nanopesticides, because they are even more concerned of the environmental and human safety, and then the safety assessment of environmental safety, which is the paramount important. And therefore, under these categories, we developed a number of different guidelines and guidance to developers. And these guidance, which includes physicochemical properties, considering these 19 parameters that on which the data has to be developed by developer. And therefore, once this data comes to the surface, then the regulators as well as the recommending ministries can take advantage of this data and recommend these technologies and products to market. The specifics, when we go into safety assessment, for example, human health, we need to get lots of data on cytotoxicity, genotoxicity, dermal exposure and toxicity, eye irritation, and inhalation exposure. And these data sets have to be developed according to the international protocols which are available. And these policy guidelines includes all that information for developer, for innovation team to take advantage of one-stop solution where they get all the information that which protocol they need to follow in order to develop data and find out their product safety and response. So this has helped particularly to lots of researchers, because I keep getting lots of feedback from across industries, the academia organizations, that they were really benefited with these information that they wanted to develop the product. Now, this environmental safety, again, the aquatic test, the diphenea test, the fish acute toxicity, and fish embryo acute toxicity, These are some very well-known tests which are required for safe product to go into environment. And therefore, these tests have also been included in the policy guidelines for developers to follow and develop data sets with. The additional assessment of nanopesticide, as I mentioned in the beginning, was also included so that the nanopesticides area takes care of those additional requirements which are required by Insecticide Board or Pesticide Board of India. Now, going from the policy and the policy framework that we have developed, I must say that India took lead, and there are a number of different countries are taking advantage from the policy guidelines India has developed. And therefore, I am part of many of these networks across different countries, as you would see that they have enacted different networks and they are developing policy guidelines, regulatory systems for upcoming technologies and product in this space. So the interactions and harmonization is a very important aspect, because if an Indian industry or Indian researcher develop a technology, they should be aware and they should be complied with the international requirement as well. And therefore, I am negotiating and in different forums for the regulatory aspects and the regulatory systems, so that the data we develop is acceptable across different countries and continents. So these are the networks which are working actively and taking advantage of the policy document and framework that we have developed. There are a number of global exchanges are happening. I'll be giving a keynote in the GSR Summit, with the Global Summit on Regulatory Science, which is organized by US FDA. And there are 250 regulators from all over the world are participating. So the whole area where we would like to negotiate, we would like to promote the data set that the industries are developing would be useful, so that the seed industries across the world can use these products efficiently without having difficulties of the country boundaries and the technology regulation differentiations. So this process is on, and I am very happy that the areas in the nanoscience that very conscious effort is being made so that the products, those will be coming in the market and those are in market, will be extensively and in detail, they will be regulated. And so the seed industries or the fertilizer industries or the end users, I am ensuring that these things will give them a higher, better and safe product for the future. In India, we have the Bureau of Indian Standards, which is the leading organization and the only organization which creates Indian standards. And they are now also involved in developing national standards in the nano agri products. And I am chairing that committee with Professor Subramanian and other members on board. So basically what we are trying to look at is developing standards as well, so that there is a complete framework available and the regulatory aspects are completely fulfilled. There is another initiative that is being taken, is the impact assessment of these standards. Those are being developed so that the impacts as well as the learning back from the user or developer is taken care while developing the national standards. Now, keeping that in view, that the regulatory framework, the policy framework, as well as the standards which are coming up in India, they are ensuring moving towards the different regulators to help them with enacting the proper technologies. And I have been discussing with many of these regulators for them to develop the national level regulatory systems, so that different products in the food area, the agriculture area, the nanonutrients, the nanopesticides are well regulated, and the sufficient infrastructure is available. On the other hand, India has invested huge amount of money in this area since last 2 decades, and therefore the tunnel is now opening up, and there are different products which I am pretty sure are going to be in the market very soon. I would now like to take you to the space where I would like you to know that there are very well-developed systems that we have been engaged with, and we are pursuing them with safety concerns, particularly that we are using microorganisms for developing nanomaterials. And they have different advantages. Well, not only the process, which is very efficient, but also have, that's a one-part synthesis. So it does not require very high-end, high capital equipments or investment. And there are no additional capping and stabilizing agents, because by physical process, the materials that we develop, or a chemical process, we develop the material, those materials are having major fear of toxicity. Whereas if the biologically routed products are developed, they neither require those stabilizers, but that means no additional chemicals. And the biomatrix formation, which occurs naturally from this process, does not allows us to load different functional materials on them. So that becomes a playground through which we can provide number of different safer material to deliver for those advantages of seed loading or foliar spread. The other advantages, of course, include high stability and monodispersity, because that's another very, very important aspect in the nanoscience area, that you have to have a monodispersed material. If there is a heterogeneous material, then the functional behavior will be different. And therefore, if you have a monodispersed material which is delivering a particular function, then your material is definitely much more efficient. And so far, with all those number of parameters and protocols that I have shown in the policy document, when they have been used to test these biologically synthesized material, none of them have shown any toxicity. So that's a very safer route which will bring the products in the market. It can also bring in the bioactive compounds, the biostimulants, the mycorrhizas, the PGP bacteria, all together on the seed. And Professor Subramanian have very heavily detailed out different processes by which seed quality can be assessed. Here, by bringing these organisms and the seed quality assessed, the user or the seed industry will be ensured that the product they are loading on the system are going to give their end user benefit and recognized by them, so that they can do better business. Now, the aspects which are very important is that the seed storage generally happens, except soybean and some other short shelf life crops, for 2 years, and therefore these all organisms have to, or the nanomaterial have to survive or remain active on the seed surface. With this kind of framework, the different products have been developed. A number of trials have been done now since 2 years. By our products on corn, soybean. We have seen the canopy covering happening, and this is in North America and Europe. The canopy coverage happens very quickly. That shows the green, the vegetative part of the plants grows very well. They have a high vigor, and then it converts into yield as well. So when we use nano fertilizer with these combinations, we have saved 25% of fertilizer, which saves around $9 in the North American perspective. Then the enhanced yield, which is 13 bushels more, gives you around $77 advantage per acre. So the net gain is around $86 per acre. And this basically brings in a very good proposition for farmers because the commodity price is going up. And similarly, here we are talking about in corn and soybean, the enhanced yield, which is even more here, and showing 28 bushels improvement, besides 25% less fertilizer input. Now, the important aspect which we are open for with industries, the seed industries, the fertilizer industries, to do a comprehensive evaluation of these products. We are willing to help them with these products and go forward to further optimize the fertilizer saving as well as the enhanced productivity at the same time. There are several qualitative improvements which happens, the grain quality, nutritional quality as well, because of the foliar and the seed delivery of these nanomaterials. And that is also, those are the aspects which are also being demonstrated through these trials across. These are some of the Indian trials that have been undertaken, where with the help of a NGO and the funding from the HDFC Bank, basically looking at how these fertilizer saving can be effectively achieved. At the same time, the soil health is also improving with these product delivery. So these are initial signatures which indicates that the 75% or 50% reduction, 25% and 50% reduction in fertilizer. Appearing interestingly from these trials is that at the 50% situation, those functions, 75% situation, the functions of chemical fertilizer is still not allowing those biologicals to perform. And the moment you go 50%, then the biologicals start performing. And then the yield enhancement goes further up. So those are very important aspects which are showing up now consistently, and consistency is a very important aspect, because farmers are looking for those products which are consistent as fertilizers or pesticides are. And therefore, these products are now getting into that route. There are more trials that we have done in different cropping systems, the groundnut, the soybean, the corn, and mung bean, black gram, and so on and so forth, cotton. So these demonstration completely and clearly shows that the fertilizer reduction is a possibility with these applications of new next generation products. Of course, drones are becoming very important interventions in the agriculture system, and with a very small quantity payload requirement for several acres. For example, this is a drone that we used for 25 liters of product. The 200 grams of product or 200 ml of product was required for 1 acre. So one can understand that one payload can do several acres very efficiently in a very, very short period of time. And these products are delivered very, very efficiently to crops. The other advantages which are very clearly emerging are that they are targeted and delivered on target. Their assimilation is very efficient in the plant systems, and there is no or very minimal leaching issues which are happening because of the existing process of in-furrow application or flooding application or broadcasting, which is giving lots of leaching issues and environmental issues and so on and so forth. So the way forward that I am looking at from the global and the Indian systems point of view, the technical bodies of knowledge, the chemistry, biology, and nanotechnologies are coming together. It's a very interdisciplinary science where these interventions are taking care of different knowledge bases, knowledge expertise, and that's where the entire gamut of new technologies are emerging. Market, regulatory, and ethical bodies of knowledge, which are market and user needs, stakeholders' concern, life cycle assessment, safe by design, responsible innovation, and precautionary principle. These are very important aspects from the regulatory perspective, and they are not to hurdle innovation, but to encourage innovation in order to for them to be ready with the data set and come up with the confidence to regulator and request for registration of their product. So that's something which is going to be a new change in our country, in the region, in the world, because the whole world is now talking and discussing and developing regulatory framework for their region and countries. From the commercial and entrepreneurial bodies of knowledge, the value proposition is a very important aspect. IP strategy is another very important aspect, and that's something which is being encouraged. Business model and supply chain and distribution channels. So we are open to work with these distributors, dealers, seed companies, and fertilizer companies to help them with the new dimensions of these products, which are nano phosphorus, nano sulfur, nano copper, nano zinc and iron, nano manganese, and nano boron. So these products are now on the shelf. They would be available, and they can be taken advantage by the different users. Thank you very much.
Thank you, Dr. Alok Adholeya. So, sorry for the interruption of power when I was introducing you, because absolutely, because we have the lecture is open for the question and answers. Let us see. We have several questions. By the participants. How aware are the farmers or the seed industry or food industry of the nanotechnology by the government of India?
Well, I would say this is an emerging area, and the product and technologies are now coming and making into the space where they would be registered. And we are expecting our regulators to work fast, and I am trying to help them. And there are others who are helping, like Professor Subramanian. So we're trying to help the regulators to enact regulatory systems so that the products can come in. Obviously, once the industries are taking the products, then the awareness among the end user will enhance.
So then the next question is very important. Are Indian growers using the nano products in their production, and is it very costly, cost factor?
Yeah. So I would say, as far as the biological route products are concerned, they are definitely not cost prohibitive. They in fact save cost for the inputs already right in the beginning. And then when they reduce fertilizers, they further save cost right in the beginning. So there is an input cost reduction. And then there is a yield enhancement. Besides the management requirement of the cropping system, that also reduces. So I would say in the nutshell, in the overall scenario, these are definitely a value proposition for end users.
Yes, thanks, sir. The another pertinent question is, are they, as the multiple products can be used, loaded on the seeds, hope their synergies and or antagonism would be one of the study in regulatory trials. Is it been done?
Yeah, absolutely. I mean, it's a very, very appropriate question, and there has to be a robust data that is required by the developer while they come up with on the table to register their product. However, I can confidently say that the biologically routed products do not have very negative or negative interactions with other biologicals on seed or in combination when they are applied. However, there is a policy guideline by which the innovator and developer have to develop those data and share with the regulator before they come to registration. So rest assured, that this data will allow, or this process will allow them to have, for the farmers particularly, will not have a problem of they using two products and one does not function because of the another.
So, yeah. Then the next question is, as technology reduces 25% of the bulk fertilizer, I think it is fertilizer only.
It says, yeah, I can read it. As technology reduces 25 bulk fertilizer only, still 75% fertilizer has still to be used.
Yes,
Is this correct, or it will be reduced in subsequent years? So as I mentioned, now it's time for developing dose-dependent trials and develop data sets to work with the product further and further in order to reduce chemical fertilizer exposure eventually to zero, and bring these fertilizers on the seed and the foliar route to take the next stage of next generation fertilizer. So they are fertilizer which are next generation fertilizer. So conventional fertilizer have to go eventually once these robust data sets and optimizations with the product development happens.
Yeah. And here is a concern, nano pesticides, the quantity would be too small and expected to be highly toxic. Will it have impact on the microorganisms in ecosystem and to applications as well?
So as I mentioned in the earlier part of my presentation, that the guidelines includes and encourage, not only encourage, but becomes a prerequisite for developers to come up with a product which are not affecting any life forms in the ecosystem per se, not only to humans, but any other life forms, including microorganisms in soil or on the plant surfaces and so on and so forth. So until and unless they qualify from that gate, they will not be able to move forward.
Yes. So, and another scientific question, any correlation between seed dormancy breaking and hot seed coat breaking for better germination on use of nanotechnology? I think Subramanian, or you can.
Yeah, he mentioned about it, but
yes.
I think there is a great deal of requirement to optimize this area. Definitely, there is a great deal of research to be done, but I understand this is a problem in some of the seeds which have a hard seed coat or shell, which requires, if that can be broken, and then the seed can have a better and efficient germination system.
Yeah. So how do you incorporate the microorganisms with other nano fertilizers?
So as I mentioned, the nano fertilizers and the other microorganisms can go together, particularly the products that we have developed. And we would be happy to go with the industries who are interested, or the researchers who are interested to learn more about. We can guide them how to test, how to demonstrate that.
Yes.
I also see a request from a participant requesting for the visit to those sites. They are most welcome. They can get in touch with me.
Yeah. Then is nano pesticides or target specific? Is it harmful to beneficial insects or ecosystem?
No, not really, because as you must have realized in my presentation, the policy framework takes care of that the product which comes out for registration have to ensure that no pesticide, no pest, or no beneficial organisms or life forms are negatively affected by these products.
So one important commercial is on what is the range of investment to register a product in India? So
we can discuss with them specifically individually, but I can say that if they are looking from the perspective of chemical fertilizer production plant versus nano fertilizer production plant, trust me, this will not be even 1%.
So Kuna, is it some more questions there?
I think we can still accept 2-3 more questions, sir.
Oh, I see. Yeah. Thank you. And how many nano pesticides and fertilizers applications are in a regulatory process in India? who are the major producers in India is presently?
Well, I do not see any product gone through the regulatory system because India still have not developed the effective regulatory mechanism. The regulators, whether it is fertilizer control order or the Indian pesticide board or the Indian insecticide board, they still have to develop, or even FSSI, they still have to develop the regulatory framework to approve products. What we are seeing in India right now, the products which are non-approved. And since until the regulation emerges, there is a possibility for industries to put product in the market, and the industries have taken advantage of that. But once these regulatory mechanisms are in place, where the nano fertilizers, nano insecticide, nano fungicide, nano carriers, or food preservative or food products are coming through these regulations, then you would see really well organized and regulated product in the market. We don't have yet.
Yes. So the last question is, any microbial protectant required when using the nanotech with bacteria?
No, not really. If they are coming through the process of regulatory system and mechanisms, no.
Yeah. I think we have questioned all the relevant ones. Yeah, I think. Thank you, sir, Dr.
Thank you. Thank you very much. I appreciate organizers for giving this opportunity in time.
Yes.
And look forward for on the side's interactions with industries and researchers. Thank you.
Yes. So, coming to the wrap up of the two talks, I think Dr. Subramanian lecture was excellent pioneering work on the research findings and for implementation in nanotechnology, use of enhanced seed quality and economic use of urea. So his work has been regarding on-site detection of seed quality, such as eNOS and electronic tongue in groundnut and sunflower, and pulses regarding to the infrared spectroscopy are very encouraging and could be tried in other species also. So here they are planning, targeting the usual TZ test of viability by for seed viability and also electrical conductivity, which also used as a vigor index in case of peas and corn, can be replaced because this is a non-destructive methods. Of course, these needs validation of the ICR and also through ACRIP or a natural seed project, and also the STAR that can be given and for other centers to adopt in other species. And when coming to the seed invigoration, nanopore on seed coat induced invigoration in groundnut and sunflower, and zinc oxide nanopores, they control pathogens, and that carbon nanotubes are very much useful in case of very useful in case of where there is a dormancy in seeds or very difficult of seedling emergence. I think this CNT could be used in tomato and high value crops of vegetables like cabbage, and wherever there is a problem of tomato. In tomato, we find very hard seeds and uneven germination, which the nurseryman complained that there is an uneven germination. This could be used, tried in tomato also. So nano emulsion have been to be tried in low vigor and problematic seed lots for better seedling emergence, like silica nanotype particles. And smart delivery is a very excellent introduction of nutrients, bioinoculants, and hormones and pesticides, which cut down the input costs and increase productivity and balance nutrition and higher germination and vigor. So this has a lot of scope in India and also in the other seed industries for the cost-cutting input and also effective use of the chemical, which are very expensive. And nanofiber technology in pulses and oil seeds could be involved in the other seed crops like tomatoes, capsicum, and also hot and sweet pepper, which are high value crops. So it is commendable that the nano urea notified sold is over 40 million bottles of, that is 4 crores last year, and which solves the urea shortage judiciously. This could be made use by all the countries where they can have a judicious use of the fertilizer, where there is a scarcity of fertilizers. So it was a very excellent presentation by Dr. Subramanian, and it was well taken by the participants also with a lot of questions. That shows that they are very eager to adopt, whether it is the seed industry or the farmers as such. And Dr. Alok Adholeya has illustrated on the global regulatory landscape of agri-nano products and technologies for seed and foliar applications. He also enlightened guidelines for evaluation of nano-based agriculture inputs and food products in India, and also different categories of nano material and loaded with AL and aluminum and aluminum converted nanoforms. Also the biological, physical and chemical synthesis and organic and inorganic composites, and biodegradable and non-biodegradable forms, and safety assessment of human health and nanoparticles environment safety points of view. And I'm happy to note that they are following the guidelines of the OECD, which is an international body. So that makes it's international guidelines. So the same way they can also adopt the ISTA guidelines wherever this quality testing is concerned. And then biosynthesis of nanonutrients and their advantages. And this has a global network of in agricultural technology adopted in several countries like Argentina, Finland, Israel, Russia, South Africa, and Germany, Australia, Japan, and Iran, and the United States. So India, being a OECD country, can easily adopt these nanotechnology. The benefits inclusive of reduction of fertilizer, enhanced yield with mycorrhiza and nano net savings to the farmer has been well driven by Dr. Alok Adholeya to the participants, and I hope all the participants will get a very good insight of this one technology. So in the end, I now invite Dr. Manish Patel, our Vice Chair of the Seed Technology Committee, to wrap up today's webinar. Dr. Patel currently is the Vice President of the APSA, and also he is a co-chair of the APSA Standing Committee on Seed Technology. He has been working as a Managing Director of Incotech India since 2001. He is a well-known figure in all the National Seed Association of India, and he has made several visits to our premises also. And he, as a seed technologist, Dr. Patel has involved on many important issues in the seed industry, like seed treatment, seed upgradation, and also seed quality enhancement. I now request Dr. Manish Patel to give a final wrap up of the seminar. Over to Dr. Manish Patel.
Thank you, Dr. Jagdish, and both the speaker, I would say brilliant speakers on these difficult topics. Because while organizing these webinars, we were trying to find the suitable speaker for justify the topics. And finally, we ended up with, both the speaker from India. And as Dr. Alok rightly said, this is a very typical topics where, hardly, the published materials and also the published commercial products are available in the global domain. But I'm happy at least to receive both the speakers and sharing their knowledge and experience. And if I just go through the, the key remarks from my sides on this presentation, then one of the, key remarks is there is a lot to do with the research on nano science and nanotechnology. And still, I think as a seed technologists who are the part of this audience here, I think we can do a lot here in terms of research and adding real value to the seeds, since this is still unexploited and untouched, science. And now we have introduced these two, the scientists or experts in these areas, and they have been involved for more than a decade in this particular area. So I think we can exploit their experience and knowledge to the great extent. And also, I think this is not about, I will say, reinvention of any new molecule or new products, but it's about bringing the current products and the research into a different forms so that it can become more effective and more cost effective, not about efficiency, but also about cost effectiveness. And I think the whole world is a witness now in agriculture that we have spoiled a lot of ecology and a lot of agricultural land by using fertilizers and the pesticides without any controls. And now, if we are able to convert these agro inputs into a nano forms, and if we develop the mechanisms to deliver to the right place, so the precision farming will be a greater part of this technology. And if we combine precision farming with nanotechnology, then I think we can control the pollution in the climate. We can bring a more consistent effect on the target objects, and we can also save the cost, and we can also improve the yield and profitability of the farmers. And I think that's where we want to go as agriculturists or as a seed technologist. So I think when it comes to the presentation content, I think most of the key topics have been covered, especially for seed application by Dr. Subramanian and by Dr. Alok, especially on regulatory parts. And it's true, still it's underdeveloping, and many countries still need to work out the framework. But meanwhile, there is a lot of gap in research, and that's where I think we all have to work to find out the right products for different seeds. And that's the, I think, only future for agriculture, because we have to save the soil, we have to save the climate, and at the same time, we have to increase the productivity to feed the world. And that's where I think this kind of revolutionary technology will only play a role. And being a seed technologist, I think it's one of the great area to work with nano products, and that can only bring a lot of benefits to the industry and to the farmers. So with these remarks, I would like to say a big thanks to both the speakers who have really justified the given topics, and also for the audience to start, a key message to the audience to start intensive research in these areas. And as a APSA, we will try to bring as much as possible the new knowledge to all of you. And also we will try to bring the collaborative efforts, since I can sense here there is a lot of need of training on this particular subject. So maybe as a APSA, we have been doing a lot of training programs, and I think it's one of the great area to organize in the upcoming months or a year to have a specialized training on, how to manufacture your own nano and how to apply or put on the seeds in a more precise way. I think that's what we can do as an APSA for the benefits of the member. So once again, I thanks all of you for joining here. I can see the participants which reach up to 145, and it's a great webinars with the support from the speakers. And thank you, APSA Secretariat, for organizing a very smooth broadcast. So with these remarks, I thanks again on the behalf of Seed Tech Committee of APSA to all the participants and both the speaker. Thank you.
Thank you. Thank you very much, everyone. So with that, we have a short administrative announcement for participants who attend today's webinar. The post-webinar survey will be shared to you after this webinar finished, and it only takes 3 minutes to help us to improve the quality of the webinar, and the certificate of attendance will be issued to attendees who complete the survey. And the presentations will be shared within next week. All unanswered questions of Dr. Subramanian will be shared to him via email, and they will be later posted on APSA website. With that, on behalf of APSA, I would like to thank the APSA Seed Technology Webinar 3 Committee, who have been working very hard to make this webinar happen. Dr. Jagadish, Dr. Manish, and Dr. Rajashikran. Thank you so much for your hard work. And today, thank you very much, everyone. Have a good day. Have a good night.
Thank you.
Bye.